Hey, hey. So I was thinking I'd do a little demo of this game library I've been working on. I've been calling it Good or the Good Engine. And it's a simple, productive prototyping engine for the Janet programming language is the idea. It's very inspired by Love 2D. And the Chickadee framework is a similar scheme framework that's more seasoned than this, more tested. But I wanted a productive Janet game engine, and I was thinking one way to show how productive you could be with it is to do a demo game. So I was thinking I'd try and live code Pong. So I haven't done it before. I think we'll probably end up doing a few things wrong, and I'll have to look at some documentation and whatnot. But I figured walk through the steps of making Pong from scratch, and maybe you get a feel for what it's like to use this engine. So we'll start with the hello world. We could use debug text so we don't have to set up fonts or anything. But oops, that should be enough to get. Oh, I always forget every time. The APIs are super similar to the ones in SDL, which is super handy, but also means you have to do stuff like set color and then call the method. So that's that, but as you can see, the text is pretty small on my screen. So we could use the setup callback. This gets called once at application boot to set the scale to 2.0. There we go. That's a lot better. A lot more legible. And now we have this. We can make other changes to our application, but I am not a huge fan of having to restart the application every time I make a change. So I added this config callback. So this comes before setup is called. Setup is called after the window is created. So you could do setup that includes things that talk to SDL things, like render related things, like setting the scale. But this is called before, so you do things like set the window size or other things. One of the config options is auto reload. So this will check in the background when the file's changed and automatically reload it for you. So here, if I want to change the color, get rid of this one, happens pretty quick. I do a little bit of debouncing in case stuff gets saved really fast, so it's not instant, but hopefully it prevents from reloading the application like 10 times in 1 second or whatever. So now we can make other changes, and they should propagate instantly. But that's only true of some changes. So one thing that I'm annoyed with other hot reloading things is that they reset everything, put you like back to your main menu screen. Instead, the stuff that's in this state that we've been passing around, this doesn't get reset. So for example, we're building Pong. We could start by putting a ball at the center of the screen. Well, we'll just put it 50-50 for now. So I save this and the ball will show up, right? If I want to be able to move the ball, maybe I want to save its state in the state here. We'll do 50-50 again. And then I want to use this here. Let's destructure it. I really like the destructuring in Janet. So this will be XY. This won't work on first reload because setup won't rerun. So X and Y on state are nil. But now that I've reloaded, they're set. But if I change this to 0, this doesn't run again. But if I reload it, it will run again. So now it's at this kind of silly halfway off the screen spot. So we'll set it to 50-50 again, but then this time we're going to add another callback, the onEvent callback. And this gets called when SDLC's events. So in this case, we're going to look for the one key when it's pressed down and it's not repeat. So that's what the event is, a key event on the key one. It's being pushed down, true is down, false is up, and not repeat. And then when we see that, we're going to instead do reset. So you're reloading on file changes, but resetting when I press the 1 key. So if I focus the window and press 1, it moves back to 50-50 because that's what my setup now says. So say we want to get it to the middle of the screen. We know our window width, the default is 800 by 600, but since we're at 2x scale, we need 400 by 300. And then let's go ahead and also set the half heights to get our middle. Do that. And then we should be able to go in here and do window half height. Does nothing when I save the file, but then when I hit 1, it goes to nearly the middle. I did this one wrong. This is height, not width. And then when I press 1 again, now we're at the middle for real. Kind of handy. It's nice that things go quickly. One thing that's sort of confusing from this example is that like this here, because it's not inside of setup, these constants will change as soon as you change them. The X and Y don't change because they're sort of like cached into the state here. A good example of that is like, say I want to get rid of this magic number for my circle width. I could set my radius to 10 here and then do circle R. Nothing will change because it's the same value, but if I change this to 35, it instantly changes. So that's not part of the setup. Also, you may notice the circle is kind of not a super perfect shape. I apologize, the font size is smaller by default in these windows, but I'm using the Brisenhelm circle drawing algorithm for now. I think I'll change this behind the scenes someday, but for now it's good enough. I don't have to include any other libraries besides SDL3, and I also have the font and image libraries included, but no GFX yet, but not against adding it. Okay, let's go back to 10 for now, and then let's try and get our ball moving. So we could move the ball in draw. Nothing is stopping you, but like most engines like this, including Live2D, it's good to separate your drawing from your physics. So over here, we're gonna do the same destructuring, and then to get our ball to move, we're gonna go ahead and just do set our X to X plus delta time, just to get it to move. And we'll do the same with Y. And zoom, flies off the screen. Delta time is like a relatively small fraction, but it's still, frame rate is fast enough that it disappears off the screen pretty quickly. So we'll go ahead and add a circle speed. It's like 0.01 just to slow it down a little. Now if I hit 1, it should go back to the middle. Oh, it's still very fast. All right, I need to multiply. There we go. That's maybe too slow. Well, let's go and try 0.5. Oh, that's pretty good. Yeah. And I reset there, but I technically didn't have to. Here, I'll get it on screen, and then if I save, it'll slow down right away. So you get what I mean? Like these, because they're in a global scope, they do get reset instantly. Okay, so our ball is moving, but it's disappearing off the edge of the screen. So I guess we may as well try and make it bounce off the walls. So I'm going to do this the way I learned to do it. I think there are probably better ways, but we'll just check if it touches the edge and flip its direction. Oh, I guess in order to do that, we should give it a vector. So it's direction X. We'll just make it X and Y will be both 1. So we'll do the same thing here, but we'll multiply by that. Yeah, so here's one issue. Because those were added in setup and I did not rerun setup with those keys, it doesn't know what they are. Well, there's 2 reasons it doesn't know what they are. One is that, and the other one is I didn't destructure them here. So here, if we do this first, now we'll see that they're nil. Before they were unknown symbols. Now the symbols are known, but the symbols are set to nil. And for this, I do have to restart the application. I want to add something to do a full reload from the error screen. But right now I don't have that. So there'll be something and I'll put it in the message on the error screen, but not yet. Okay, so now that we have a direction, what we need to do, so I think we're hitting the bottom edge first, right? Yeah. So let's say our bottom bound is our Y plus our circle radius. So we want to say if the bottom bound is greater than window height, then we want to change the delta Y to be negative delta Y. So I think this will do something, but I think it does the wrong thing to begin with. So let's see. Yeah. So this is classic sort of game physics-y thing or whatever, is that now our delta Y is flip-flopping very quickly between positive and negative numbers. So it never actually escapes the edge. So we got to do one more thing here, which is that we need to set our Y to be the window height minus the circle radius. And then I think it'll bounce. I forget if you need to go one more. No, that's good. Okay, great. So now we're bouncing. So this will bounce us off the bottom. Let's go ahead and do the other 4 bounds. Top, left, right. So the top will subtract. The left will subtract. This will add. These will be X. And then I think we can adapt the same thing. So bottom bound and then top bound will be if it's less than 0. Then we'll put Y at circle radius and flip the Y. And then for left, if left is less than 0, we'll set the X to circle radius and change delta X instead. Okay, that should be 3. I think this is the next one we'll need for our next bounce. So this will be window width, and this will be dx. So the right bound we want window width, yep. And then dx becomes negative dx. Yeah, it bounced back on screen because it was beyond one of those boundaries and got reset to the edge. So that's looking good. Let's speed it up a little and see it bounce off all the walls quickly. Great. That looks good. So our next step is going to be adding our paddles. So we need like a left and a right paddle to bounce the ball off of. So how should we do this? I guess we know we're gonna need paddle, left paddle X, left paddle Y. I'll just put 10 and 10 will I think. Same thing for right paddle. Okay, so for the left paddle, I think 10 might actually be good here. For the Y, let's put it at window half height. And then subtract half of however tall we're going to make our paddle. Let's make paddle height, I don't know, 10 seems too small. 40. Cool, let's do that here too. And then our X, we want to be on the other side for this. We want window width, so we want it all the way at the other side, minus what should our paddle width be? Maybe 20. So this will put it just barely on screen. Let's add 10 to make it close. And then I'm gonna cheat a little here. Now that I've added my new state, I'm gonna go ahead and hit 1 on the window, so those are set, so now I can use them. Ideally you'd be able to error and come back, but that works for now. So let's go ahead and get them drawn. So for, I like to have both on the screen at the same time. Let's destructure out our new paddle. We could abbreviate these, I guess. LPX, LPY, and then same thing, but for right paddle, left with right, and then right. Okay. Draw rect, so we'll do it at LPX, LPY, paddle width, paddle height, save. Hey, oh, it's a little chunky. Let's lower the paddle width to 10. Looks pretty good. Okay, let's add the other paddle. Oh, slot is not a number. Did I forget one of them? I'm confused. Oh, no, it's actually a mistake. I was hoping it was a state problem. Line 72. RPX, RPY. Paddle width, paddle height. Bad slot 1, so it doesn't like RPX. Ah, typo. How about now? There we go. Now we got 2 paddles. Okay, that ball is stressing me out. Let's slow it down a little. Sorry, you've probably been watching it this whole time. It's a little more peaceful. Let's go ahead and make our paddles bigger. Otherwise, I think it'll be a little too hard. Maybe 60. Yeah, it's good enough. We'll see. It depends on how fast they are too. I guess I might as well anticipate that we're going to have a paddle speed here. So let's go ahead and make the paddles move now, and then we'll deal with making them collide after. So we're going to need our paddle data destructured here too in tick to do the physics update on them. So we got our ball stuff. Let's get our paddle stuff. And then we should be able to do something like this. Let's add it here at the top. You could use the on event hook for checking when the keys are pressed, but that's less reliable than the key down API for things like this. I think for the right paddle we use Q and A. I think it'd be good technically to make sure this works for all keyboard layouts. I'm doing sort of a US ANSI standard keyboard bias. And you could definitely check for keys that are in a position if that's what you're looking for. So Dvorak people and everybody will have no problem. But for now, in this tiny demo, we'll do this. So this will be the left player, and this will be the right one. And then when you're pressing Q, we want to move the paddle up. So we'll do left paddle Y should be, we'll subtract left paddle Y from multiply dt by paddle speed. And then we'll see how that speed feels. I guess I may as well do the other direction too. And we'll add here compilation expected 2 or 3 arguments to if. On 48. Oh, right. These ones. Yep. That's fair. Okay. Ooh, we're very, very slow. Okay, let's speed up the paddles a little bit. How's that? We could go even faster. 25? That feels about right. That's like enough. It's not instant. Oh, I'm doing last key, it looks like. If I hold both down, I don't stop moving. But that's a thing for another day. So let's go ahead and duplicate this for the other paddle, but with the P and L keys. And then change left to right. And same with these. And then let's see. Hey, nice. I can move both paddles now. Cool. And then all we got to do is make the ball collide with them. So we're going to do similar to our wall collisions, but for paddle. So if we want to maybe copy our left and right ones and modify them. So for our left side, we want, if the left bound is less than, what will it be? It'll be left paddle X plus paddle width. Do that, only we need to also check that we are within the paddle top and bottom. So, oh yeah, we're sliding now. That's that makes sense. So, we want to be less than our paddle top. So that'll be left paddle Y. Oh, no, the Y is less than left paddle Y. And Y is greater than left paddle Y plus paddle height. Out there, that there, that there. Okay. And then the other mistake we're making is that this is resetting it to the wrong position. We need it to be circle R plus this, the thing that we ran into. Only we don't need to nest the pluses. So now I think, let's bounce off the paddle, see if it works. Nope. What did I get wrong? Left bound. Y is, oh, yep. These are backwards. Wait for it to come back around. It would be smart to have fast forward, maybe. There we go. It's nice. And then I think if it misses the paddle, we'll test while I type. If it misses the paddle, it should... oops, I already copied this. Yeah, it hit the wall, right? I wasn't looking. We'll watch in a sec. So then for the right paddle, we want to check that the right bound is greater than... oh, yeah, no, just RPX, because the corner is right there. And then we need our ands again. So then in these conditions, we're going to do like this. I think these stay the same. So it should be fine like that. And then let's see. Oh, maybe I didn't save in time. Right bound is greater than, yeah. I have the problem still where I'm resetting it to the wrong location, but let's see. Nope, I have something else wrong. So the right bound has to be greater than, oh, yep. That'll do it. Boop. Wait for it to come back around. Yep, okay, good. I'm resetting it to the wrong position still, but it did react, so that's good. So now we'll do subtract circle width from RPX instead. And now it should bounce like we expect. Nice. Okay. I think for this demo, I'll call that good enough. I'll leave scoring as an exercise for the viewer. We would just change two of these conditions and then put a score up on the screen, but this plays like Pong. Hopefully it wasn't too long. I would call that productive in that I didn't have to do a lot of rebuilding. I wasn't really thinking much about, build steps or compiling or anything. I was just kind of watching my changes as they happened. I like to think this is as close to kind of the REPL-based development as you could get with a tool like this. Of course, it's not. We don't have an attached REPL, though you could definitely use the Spork one to attach a REPL. But yeah, thanks for watching.